All right, welcome and welcome to Introduction to Data Types. Okay, you now have a nice introduction to variables. I'm not sure if you understand them or not, but it's kind of hard to understand until you actually do these things, right? And so, but hopefully you have at least an idea what a variable is all about. Now, the next concept we need to talk about is data types and how it relates to a variable. Another very important concept when it comes to programming. This is something that you'll use not only, or talk about, I should say, not only when it comes to each programming language you'll ever deal with, but also databases and so on. Okay, we deal with data types there also. So let's get in and talk about understanding the concept of a database, of data type, the different types of data, understand how we use data types with variables in programming. Okay? All right, when you instruct your computer to allocate some space, okay, so that's what we're going to be doing. We're going to be telling the computer now that I need a variable. All right, I'm going to show you how to do that in an introductory program for this week. Um, you need to also, to do that, the computer wants to know a little bit more, okay? It wants to know what type of data you're going to store in that variable. So it's very picky, okay? Not all languages do this, but Visual Basic it does. And we'll talk about that when we get to those other languages. But for this particular language, we'll sit back and say that this language wants to know what type of data is going to be in there. Okay? It's called a strong fitted language, okay, in that case. Why, you ask? Well, the computers are picky things, and it doesn't want to give up its resources so easily, okay? It wants to be very specific on the resources needed, and by resources in this case, I'm talking about RAM. So a computer only has so much RAM. In today's world, there's quite a bit there, but remarkably, programs take it up quite a bit. I mean, it's amazing how slow computers can actually get based upon the software you're actually running. So we as professional software developers we want to allocate our resources, and we want to do so to respect the resources that are there and just not take up too much space if not needed. Okay, it will then allocate space on the data type. So if we tell the computer that for this particular variable we want something in there, it will allocate enough space to do so. Versus we don't do that and it just allocates the maximum amount of space no matter what. That becomes very inefficient. So we want to tell in this programming language how much space is actually going to be needed, and we'll do that by referencing the data type. It also wants to know, okay, based upon the data that you have in there, that it's dealing with the data correctly, okay, based upon what you, the programmer, actually wanted. So by specifying the data type, it will deal with those data types accordingly. And you'll actually see that work as this course progresses. So for these two reasons, probably two reasons you don't quite understand yet until you actually get out there and see it, is really the reason why we need to tell the computer what type of data we're going to be using in our variables. Okay? So when we programmatically tell the computer to allocate space, we need to tell it the kind of data that will be used in that space. Okay? There's four main types of data. It's kind of the same thing in database world in every language that's out there. There's a few extra ones here and there, but when I talk about these four main ones, these are the ones you're going to probably use 95, 96, 97% of the time, if not more. Okay? There's text and strings. There's numbers, there's dates, and there's booleans. Okay? For text and strings, it's just that. It's an alphanumeric characters. Okay, as I mentioned before in the previous video, most of the time you're using variables for numeric type values, but you could use variables for alphanumeric characters based upon what you're doing, and you will in this course do so. And for the things you may put into these variables, it could be a name, an address, social security number, and so on. Again, these are alphanumeric characters will never be used for a calculation. So even though social security number is a number, you'll never use it in a calculation. It actually has dashes in it, okay? Student number, it will never be used in a calculation. Get the idea? Okay, so these are text and strings. Very easy to identify. The other ones are numbers, okay? Numbers are data that can be used in a calculation. Wage, hours, inventory, so on. Those are the types of things that we would, use numbers for based upon our inputs. Numbers can be one of two things. This is very important. So I want to slow down here for a second. You can either have a whole number, which is called an integer. So a whole number could be number of students in a classroom. It could be number of books on a shelf. It could be anything that's a whole number. It would never be, what do you say, fractionalized in any possible way. Okay? A decimal, on the other hand, is just the opposite of that. It would have a decimal to it. It would be fractionalized. And so in that case there, you could have currency, right? All currency would be decimal. So if I owed you $3.23, that's a fraction, okay? So that's a fractionalized number, which is basically a decimal. So when you're looking at numbers and you determine that's going to be a number, you need to ask the question, is it a whole number or is it a decimal? If you don't know for sure, you need to ask either your users or whatever the type of data that you're dealing with, all right, in that case, all right? But we got to differentiate it for the computer. The computer wants to know exactly what type of number we're dealing with. Just not that it's a number, what type of number, okay? Dates. That's pretty easy to understand. I don't think I have to elaborate on what a date is. Birth date, an order date, a hire date, whatever. Anything that deals with dates, we can keep it as a data type, and it will handle it accordingly, okay? And Boolean, finally. You don't use these very often, but you do use them in programming here and there. They're true and false. They're flags in the programming world. You may not know what I mean by that, but later on you may use this flag, okay? As a matter of fact, we will use this flag probably in I don't know, 3 or 4 weeks we'll use this flag. And so you'll use a Boolean flag that's either on or off. It's really nice to use in programming to be able to indicate something happened somewhere else. And so based upon that, if something happens somewhere else and the flag is on, you may do something. If it's off, you may do something else. Hold on to that a little bit. Like I said, we'll be covering that here in a few weeks, or seeing one of these being used in a few weeks, I should say. Okay? All in all, how we use data types in programming is pretty simple. Based on the variable that is needed, we need to determine what type of data we will be holding. It's just that easy. If it's a number, you got to ask if it's going to be an integer or a decimal. If it's a string, it's a string. If it's a date, it's a date. If it's a Boolean, it's a Boolean. Pretty easy, right? We'll dive into this and expand on this as the course progresses, but right now, let's just keep it as simple as possible for your understanding. That's all you really need to do, okay? Now, as I said before, every language deals with these data types a little bit differently. It's not worth really going into how they do it differently. But when you get to those languages, you want to ask the question, how do you deal with data types with your variables? And if you do so, the answer will come, okay, very easily. It might be a little confusing at first, but for the most part, it's about the same thing. You just need to ask the question on how. When it comes to Visual Basic, it's pretty easy. In Visual Basic, you're going to say, I need a variable. And if it's a string, you're going to tell I need a string. If it's an integer, you're going to tell it needs to be an integer. If it's a decimal, there you go. You say decimal. And if it's a date, it's a date. And it's a Boolean, it's a Boolean. It's just that easy and it's spelled out that clean. All right? And like I said, when we get into our first program this week, you'll see how this works. And it's actually pretty simple. All right? So, okay, we just declared our variables, so I'm going to ask this question. When should we initially identify these data types? And I hope you're screaming at me right now and saying, Bob, it's when we design this thing. And the answer is, you are right. Way to go. I'm proud of you. And so let's go back here and let's pull these things up. So we get down to number 8 here on this list, and we determine data types. Look how far we've come here in a short period of time. So we determined our variables. Now what I need to do is determine our data type. So my question would be, what is number 1, number 2, and number 3? You might sit back and go, I don't know. Is it a whole number? Is it a decimal? How would you find out? Well, once again, you're writing a program for somebody. Somebody's going to use this program for some purposes. If you don't know what they could possibly do in this, what their intentions are, just adding up whole numbers or adding up decimals, you would go ask that question to them. What do you want to be able to do? You want me to be able to put 15.5 in there, 15.75, 13.345, a pi, 3.14, whatever, whatever, whatever. Or do you just want whole numbers like 2, 3, 5, 7, 9, 20, 50, 90, whatever, a whole number and no decimals behind it? For our sake and for this, so what we'll do right now for our sake is we'll go ahead and make this a decimal and allow for decimal input. And so what I would do right here is put, I'm going to just kind of do it this way, a D and a D and a D. So these three would be that. So the sum, if I'm, what would a sum be? Okay, so it's going to be a number, obviously. Okay, it's not a string. These are all numbers. What type of number? Well, if we're adding up fractions, fractional type data, obviously it needs to be able to handle that. So that's going to be a decimal too. And the same thing for a product. It would need to be able to handle those decimals. So this would be a decimal. Pretty easy. It took me 1 second to think about that. And I'm going to tell you, okay, by doing it this way, when we get to our program, you're going to see how easy it is for us to then do the programming piece of this, to make this all work just by the little things we're doing right here. Okay? So that is data types. The next piece we talk about is determine the scope, write the test cases for all the paths, and test the logic. We're going to come back to that a little bit more next week, all right, as we continue on with our discussion. We're going to stop now, and we're going to get into how to do some calculations. That's the next video. And then finally, writing our first program based on this design. All right? I will see you